Hello students, Dr. Wang is here. In this video clip, I'm going to teach you how to conduct CAPM analysis. So CAPM means Capital Assets Pricing Model. This is a big hit in the classical finance theory world, and it is invented by Dr. Harry Markowitz, who was a professor at the University of Chicago. And this model is used to estimate the required return for each individual stock based on the performance of the entire market. And 70% of the finance professionals are using this CAPM model to estimate the required return for stock. All right, so in this video clip, in this Excel project, I'm going to ask you to conduct the CAPM analysis, and you will need to find the very important things called a beta. Okay, that's the first and foremost important thing in the CAPM analysis. And then there are three methods you can use to get the beta. So what is a beta? The beta is a multiplier. Okay, this is a multiplier. So what is a multiplier? Right here, let's say if you have the stock return, let's say I stands for individual, R stands for return. And then that's a raw return. We need to take off the risk-free part of it. So RF stands for risk-free return. So that's the return everybody could get. This is the return offered by the Treasury bill of United States. So you know the U.S. never default on the debt payment. So the Treasury bill issued by the U.S. government is having no risk at all. So right now, the risk-free rate is around 2.5% a year. Why do I need to take off this RF? Because this is a rate everybody would get. So if I take off RF, then the rest of it, I would call it risk premium. Okay? Or the return adjusted for risk, okay? Or a return adjusted for risk. So risk premium is actually a return. It is a return adjusted for risk. If you take away the benchmark, which is a risk-free rate, then the rest would be associated with the risk. And of course, higher risk will lead to a higher required return. Okay, so if the stock is riskier, okay, with more risk, then this risk premium would get higher. So that's for the individual stock. And in this exercise, the stock you are analyzing is GE. Okay, GE is General Electric, and that's a very old firm in the United States who produce electronic devices and appliances like refrigerator, microwave, and stuff. All right, you also have the market. All right, you also have the market, which include like 3,000 to 5,000 stocks overall. So you have the market return. I use M stand for the market minus the risk-free rate. So that's the market risk premium. And of course, it is a return adjusted for the risk level. So you have this individual risk premium on one side and the market risk premium on the other side. So you want to make this equal to, okay, just to make it equal to beta times this market risk premium. Okay, so the idea here is if the market risk premium changed by 1%, the risk premium would change by beta percent. Let's say if beta equals to 2, right? So let's say if beta equals to 2. So you will use a 2 multiplied by the market risk premium. So if this is 1%, then this would be 2%. So the whole idea here is we're assuming the stock risk premium would change as a portion or as multiples of the market return change, right? So that's how we interpret this CAPM. And in this exercise, you are going to get the beta. So it may not be 2, it may be 1.4, it may be even negative number. Who never knows? So we just need to do our estimation and then find the correct beta. All right, and I offer you three methods to do it. The first method is to get a chart and then find the best fit line. Is actually geometry. The second method is much simpler. You just use a slope function of Excel. And the third method, you're going to conduct regression analysis. So a regression analysis basically means you have a y, you have a plus b times x. Okay, so you want to estimate the number for b holding y and x known. All right, so here, let's just get started. So delete this column with color. So right here, I have a Standard & Poor's 500, and that basically a combination of the best 500 stocks in the U.S. market. And I have my individual stock, GE. And right here, I got the index points, which are in thousands of points, and GE is in dozens of dollars. And right here, I also get the T-bill rate. The T-bill is the debt security offered by the Treasury Department of the United States. Okay, so that's our risk-free. The T-bill is already in percentage. I got it from the Federal Reserve Bank of St. Louis. And I also have this GE. I got it from Yahoo Finance. Standard & Poor's 500. I got from Yahoo Finance. Before I conduct analysis, before I use RI minus RF and using RM minus RF. Well, first of all, I need to have these returns. I need to have the returns of the risk-free assets and also the return of the individual stock and the market. So right here, not everything is in return, not everything is in percentage. So first, I need to get all the returns. And of course, I have these three assets. So I just copy, right? And then I paste it here, right? So I want to calculate the returns, and remember, how do you get the return? The return today equals to the price of yesterday, price of today, okay? Or let's say the new price minus the old price. The difference will be divided by the old price. Okay. For example, if you want to get the return for April of 2013, you need to use the price of of April minus the price of March, okay, and then divided by the price of March. And this is a formula you really have to memorize, okay? So this is in percentage. So you get a 3.6%. Well, you don't have a return right here. Think about why. Why you don't have a return here. If you want a return right here, you would need a March return, a March price, okay, which is this number minus February price. But you don't have a February price on the top, right? So you cannot really calculate that return. So that's why you have to leave this blank. All right. So after I have finished this return for April of Standard & Poor's 500, then I just drag it to the right. So this is the return for GE. Once again, it follows the formula of a new price minus old price divided by the old price. Okay, new is in the blue border minus old, okay, in the red color divided by the red. Okay, and then I just highlight them, drag it all the way down, or just double click on the right bottom corner to have all the returns generated. Okay, and for the T-bill, it is already a percentage as I downloaded from the Federal Reserve Bank. The thing is, I want it to be in percentage as well, so this should be 0.09% per year. Okay, not 9%. You know, 0.09 is the numerical format for 9%, but it's really not a 9%. That's just so big. So I need to divide this by 100. So and then I change the format to percentage with a 2 decimal, and then I drag it all the way down or double click. So these are the annual returns. Okay, these are the annual returns. Well, that's you can see that the Treasury bills return is actually increasing, and the thing is, if you use this annual return, okay, if you use this annual return, then you have to make this returns for the stocks in the market also in annual term. So my problem is these are monthly returns. Okay, these are monthly returns, whereas the T-bill is annual return. So what you need to do here is to divide the return by 12. So once you get so you see once you get this annual return, which is 0.09%, you divide it by 12 to get a monthly return. And you know the number will be pretty small, but it's okay. Okay, so your monthly return is actually calculated like this. Right. So the next step is to get these risk premiums. Okay, as I said, risk premiums are returns adjusted for risk. Okay, risk premium. Okay, I need to do it for the market. Now let's just say Standard & Poor 500. That's for the market. Okay, and this I also do it for the individual stock, which is GE, or just merge the cell. Just merge the cell. Okay, so the risk premium will be based on the return of the assets minus the risk-free rate. Okay. Oh, that's a very long number. It's crazy. So I just need to reduce the decimal. As you can see, it really doesn't change much. And then right here for GE, I need to use this minus the T-bill rate. Okay, well, that's also a crazily large number. Okay, then just drag it all the way down. Okay, just drag it all the way down. So now I have my risk premium for the market. So I just mark it as market, and then this would be the individual stock. Okay, so now after I finished this risk premium, it's time for me to conduct the analysis for beta. So this would be my X values, and this would be my Y values. There are three ways to do it. One way is to get the chart. So let me select both columns, okay, with the titles included. And then I'm going to hit insert. All right, I'm going to insert this scatter chart. Okay, and then I wanted to have these lines. Okay, just this scatter chart. Okay, with no lines. Sorry. Okay, so the individual stock here is actually GE against the market. So that's how I want to name it. And what you see here is the x-axis is the market prices, market returns. The y-axis would be the GE's returns. Okay, so each dot here is actually a monthly data. So this is a monthly data. This is another monthly data. So each dot on the chart is a monthly data. So you have, let's say, 30 months. Therefore, you have 30 dots plotted on the chart. And then you need to find the best fit line of this chart. So what you can do is you right-click on it, and then you add a twin line. Okay, you add a twin line. All right. So after you add a twin line, and you can just edit right here, and you can say display equation on chart. Okay, display equation on chart. So make sure this is checked. All right. So here is your equation. And let me just right click on the select data. Just want to make sure the x values and y values are placed in the right place. Okay, so my x values are in H, okay, and my y values are in Y. So these are all in the right place. So these are my x value, these are my y value, these are in column I. All right. Okay, so right here you can see that the equation is y equals to 0.002, which is a very slim number that is very close to 0, so I can just skip that. Okay, I just record negative 0.5543 x. So that is my beta. So that basically is saying the RI minus RF, which is my risk premium of the market. Oops. Okay, equals to negative 0.5543 times Rm minus Rf. Okay, so now I can get my beta. My beta basically is this number, negative 0.5543. Okay, so I can just write it down. Beta equals to negative, okay, negative 0.5543. All right, so that's one way of finding the beta. Another way of finding the beta is actually much simpler. Instead of creating the whole chart, I'm going to get the slope. All right, so I just use a slope function of Excel, and this slope function, it actually asks me about the y's. The y values would be the individual stock excess return. Okay, just select them all and separate by comma. All right, and then my x values would be the market risk premium. Okay, and then close the parentheses, hit enter. As you see, the slope is a negative 0.5543, which is exactly as given by the chart best fit line. So this 0.5543 is the slope of the best fit line. Why do we call it best fit line? Because this line, the distance of each data point to this line, the summation is a minimum, okay, compared to other possible lines. So basically, this line is close to all the points. Okay, it's close to all the points. That's the best one. The third method is actually required to do regression analysis. Okay, regression analysis. So regression analysis basically follow the same whole idea. You gotta use the y value. Okay, you're gonna use the y value, and it equals to a plus b times x. Okay, so that's the whole idea of regression analysis. Before you do this work, I want you guys to hit File and hit Options, right? And make sure you add in all the regression package, right? So hit Add-ins, and then you will see Manage Excel Add-ins. I want you guys to click Go. All right, and then you will see Analysis 2-pack. Do you see that? I want you to select that, okay, and hit OK. All right, now I want you to hit the Data tab. You can see the Data Analysis option is available now. We just have it installed. All right, I want you guys to click on the Data Analysis, and then I want you to move all the way down until you see Regression. Do you see that? Click on it. Okay, hit OK. Now it's time for you to input the y values, and of course the y values would be the stock's excess return, and the x values would be the market excess return. Well, when I say excess, it is the return in excess of risk-free, so it's the same as the risk premium or risk-adjusted return. All right, and then after you select the y values, the x values, and then just hit OK. All right, just hit OK. And this is basically telling you, okay, there are two important numbers, okay? So one number is the intercept, and another number is a coefficient for x. So basically, it's telling you if you use this data, these are your y values, these are x values, then the relationship between them is estimated as the following. Y would be equal to the intercept of 0.00, well, I just copy it. Copy. It doesn't let me. Copy. Okay, this intercept plus, okay, the x coefficient, which is a negative 0.5543. Okay, times x, right? So this is the intercept, and this negative 0.5543 is the slope, and it's also the beta, okay? Once again, beta is the multiplier, okay, which is changing between the market performance and the individual stock performance. Okay, so your beta should be negative 0.5543. So we have done three methods to estimate that. First, we got this estimation. All right, so we have this beta estimated. Okay, using the chart and the best fit line, and the slope of the best fit line is this beta. Okay, and the second is to use the slope function of Excel. So that's the easiest. Okay, the last method is using this regression analysis. Okay, the beta here basically is telling me that if, so let me just write it down right here. So if market increases by 1%, then GE would decreases by negative 0.5%, negative 0.55%. Okay, so that is saying GE has the opposite direction compared to the market. So if the market is moving up, GE is moving down. If the market is moving 1%, GE is moving 0.5%. So not only GE is going the opposite direction, but also GE has less movement, okay, smaller amount of movements compared to the market, or you can say GE is less risky compared to the market. Given the long history and large size of this company, it is definitely easy to believe that GE is safer assets compared to the market. The only thing is right now the U.S. stock market is doing pretty well. Okay, it's doing pretty well. So you definitely want to avoid having GE because when the market is going up, GE is going down. So you want to avoid that when the stock market is going up. So when do you want to buy GE? You want to buy GE when the market is going down, right? So if the market decreases by, let's say, decreases by 1%, then what will happen to GE? Then GE would increase, right? It would increase by the same figure, 5.55%, right? So that's when you want to hold. It's positive 0.55%. That's when you want to hold a GE. Okay, you hold it when the market is actually not doing very well, and you want to hold the stock that goes the opposite direction to the market. So this is your strategy when the market is doing